Now let's see the cascading in 8259. First question is why we need to do cascading, right? If we want more than 8 interrupts in our system, we need to go for cascading, and there is a concept called master and slave that we need to implement. So here you can see the basic diagram of cascading of 8259. This is your microprocessor. As you know that on INTR pin you will get the interrupt from your 8259. So the first master will be connected with INTR pin and it is connected over here. Now it is not compulsory that on each interrupt pin you need to connect your 8259 chip. It is not always required, right? As you can see here on IR0 you are having one 8259 chip is connected, IR3 one chip is connected, on IR7 one chip is connected. IR5 and 6 are not used because there is no interrupt, and there are two devices attached on IR1 and IR4 on master. Same way on slave, as you can see here on first only one device is connected, here also one device connected, and here also one device connected. Again, on which part it will get connected, that depends on the user. So it is not compulsory that it is always starts with first. So this is the basic diagram of 8259. Now what happens in basic procedure? Your slave, suppose this device want the service, so what it will do, it will generate the interrupt. So 8259 will tell your master that I need a service. So 8259 will tell the microprocessor will send the acknowledgement, and based on the acknowledgement it will get the what ISR, right, vector number, and on that vector number microprocessor will go and run the interrupt service routine. Thing is, suppose this device wants the service, so it will tell the master will tell the microprocessor. So now master need to give the vector number. Now this 40 is the vector number of master, not of slave. What we need to send is, we need to send the vector number of this. Suppose it is 50, then we need to send this 50. What this mean? We need to, and we know that this vector number we do in initialization process, right? So in initialization process, as we have already discussed, we need to do some basic task, right? We need to set the priority, we need to set the vector number, we need to decide triggers and all. So same way this vector number are decided at initialization. So what this scenario tell us, that you need to initialize all your 8259, all, not only masters, but you need to initialize your slave also, because if something comes from slave you need to give the vector number of slave. So initialization is important. So now let's see how initialization performs. In initialization, in cascading of 8259, there are 4 things that you need to take care. First, 4 steps are performed when initializing your cascading. Initialize all 8259, as we have discussed. You need to initialize your master as well as slave. You need to decide what will be the priority of each interrupt. You need to decide the trigger, you need to decide masking, and you need to decide your vector number for all the masters and slave. Next thing that you are supposed to do is, you need to give the vector number to all your IR, master and slave. As we have already discussed, you need to give the vector number to all your master and slave because it is needed. Next thing is, tell your master that on which line you are having slaves, because here I am having slave, here I am having, here also I am having slave, and here also I am having slave. Why I need to tell my master? Because once my 8086 ask me that send me the vector number, I know that here I don't have my own vector number, I need to go to slave. So your master need to know that at which location it is having slave. So at that point of time it need to send the vector number of slave, not the vector number of itself. That's why your master need to know that where my slaves are attached. So third thing, at initialization you need to tell your master that which are your slaves. And fourth thing that you need to do is, you need to give the slave identification number, SIN, slave identification number, to each slave. Now why that number is needed, that we can understand when we'll see the working of master slave configuration. Okay, so now in this video we'll see the working of master slave configuration for 8259, right? Before going to that, there are 3 lines cascading lines, right, as you can see here, and CS signals are used, and as you have seen already in the 8 to 5 9 architecture also, that these lines are used. So as you can see, CS line indicates that it is a master or slave. So that for that purpose you are using this line, CS line. So if it is 1, we can say that it is master. If it is 0, we can say that it is a slave. So by this, your microprocessor will get to know that, or each chip will get to know that it is itself working as a master or it will working as a slave. And these cascading lines are used to identify that which slave gets selected, right? So how it will work, that we'll see in the working. So let's straight go to the working. So how your 8 to 5 9 cascading works. So step 1, suppose interrupt occurs from any slave. So suppose we assume that in our case this device will throw an interrupt, right? So what happens in next step, this interrupt occurs, so this slave will indicate this thing to master, and this master will indicate it to the microprocessor on INTR pin. If everything goes well, in second step your 8086 will send INTA signal, first INTA signal, right? We know that it will send two INTA signals. So it will send first INTA signal not only to masters but to all the slaves. Get it? So on second step, once it will reach, your request will reach to microprocessor will send the INTA signal to master as well as all these slaves. So that will be our second step. So if interrupt occurs in second step, this is given to master is send it to microprocessor send first INTA to all the 8 to 5 9 chip, masters as well as slave. Get it? Now this step 4 is very important, and here the work of that CAS line, cascading lines, will come into picture. You can read that master inform all slaves after microprocessor send the first INTA signal, and before it send the second INTA signal, this is what happens. So after first INTA signal, master will inform all slaves that which one got selected, right? Suppose it is possible that this your this device as well as this device, both device will send the interrupt request. So now both these slaves feel that I got served or I got served, but they don't know that which one got served. As this is on higher priority, your this INTA signal is for actually only for this, but they don't know right now that this one will get selected or this one will get selected, right? So this one will get selected. So what master will do, master will send here the number, suppose 000, to all the slaves. So now all slave will receive this number, and as I already discussed that each slave is having their identity number. So now this slave will check, is it for me 00? No. Is it for me? No. So this will get to know that my interrupt is still in pending, and currently this one will get selected. So this slave will send the vector number directly to 8086 using data bus, right? So in step number 4, because we know that normally your 8086 will send two INTA signal. On first INTA signal, it will confirm that your interrupt will get served. On second INTA signal, we need to send the vector number. So during this time, here on step number 4, your master will do what? Master will send the message on which line? Cascading lines. To whom? To all the slaves. What it tells? Which slave's interrupt will get selected. So that slave, now microprocessor will send the second INTA signal, and slave is already knowing that my vector, my interrupt gets selected. So selected 8259, it is a slave or a master, send the vector address to microprocessor on data bus. And data bus, once the microprocessor will get the address, it is a normal procedure. Now microprocessor will find out the IVT, it will execute the interrupt service routine, it will get over, and it will send end of interrupt command, right? So this is the normal procedure. This is how your 8259 cascading works. So that is the use of CAS line to inform all your slaves that which interrupt got selected. When CS will be sent between pulse 1 and between pulse 2, here it will get informed to all the slaves. Yes. Okay. Which address will be go? The address of particular vector will go. It will given by slave or it can given by masters, right? So this is how your 8 to 5 9 cascading works. I hope you understand. Thank you.